In 1907, a clerk working in a patent office in Switzerland was watching a man cleaning windows instead of, whatever it is people in patent offices do, and he thought to himself, what would this window washer feel if he fell off his ladder? So mortal terror would be the answer most of us would come up with, but most of us aren't this patent clerk, who happened to be Albert Einstein. Einstein's thought experiment became the basis for his theory of general relativity. Now, we've previously covered Einstein's theory of special relativity, which told us that time and distance were not fixed, and set the speed limit of the universe as the speed of light. It also gave us the equation E equals mc squared, which says that mass and energy are equivalent. It explains stars and how black holes are created, and something called time dilation. General relativity explains the rest: gravity and space and the very fabric of the universe. And we are learning about that right now.
We choose to go to the moon.
The rum-tum-tugger is a curious cat.
100 billion other galaxies.
Right now, you like me.
Welcome to 5 Minute Trivia, where we're making the world smarter 5 minutes at a time. I'm your host, R.M. Zuberi. So, when we left off, we had a window washer who was having a bad day. But it was a good day for physics because Albert Einstein figured out what gravity really is. Einstein was famous for conducting thought experiments first and then working out the math later. In this case, he realized that the way everyone thought about gravity since Isaac Newton was wrong. You see, Newton's law of gravity theorized that gravity was a force that existed between objects that just came from the objects themselves. Or, in his own words,
every object in the universe enacts its own force of attraction on another object.
Okay, but what is that force? Where does it come from? So, back to the falling man. Einstein hypothesized that a free-falling window cleaner would feel weightless because there's nothing pushing back up on him. Weight is the force exerted on an object due to gravity. If you stand on a bathroom scale in outer space, it'll say 0 because there's no gravity. But if you're standing in a spaceship that is accelerating upwards, the force of the acceleration will push the scale up towards you, and it'll show that you weigh something. You can do this on your own in an elevator. When an elevator starts going up, the initial force of acceleration will briefly make you weigh more as it accelerates towards you. This shows that gravity and acceleration are the same thing. If you're in a spaceship that accelerates at the same rate as Earth's gravitational force, you'll weigh the same as you do on Earth. So that's you, but what about light? Like if I'm in this rocket accelerating up and I shine a light from one side of the ship to the other, what happens? Einstein says that the height of the beam would be slightly lower on the other side. Acceleration and therefore gravity would bend the light ray. This bending of light happens because that's the shortest path to the other side of the ship. On Earth, the shortest distance between 2 points is a curved arc rather than a straight line. If you've ever looked at flight maps, you'll see that planes often fly in curved trajectories across long distances. That's why. So if the shortest distance between 2 points is curved, maybe space itself is curved. And maybe that's gravity, something that causes a curvature of space. If you put something heavy on a trampoline like a bowling ball, it'll make an indentation. The more massive the object, the deeper the well it creates. If you then place a smaller object on that trampoline, like a marble, it'll roll towards that larger object, just like a planet orbiting a star. That's how gravity and orbits work. The star deforms space, and the planets fall towards it. Now, technically, space isn't just space, as in it's not 3 dimensions, but actually 4. That 4th dimension is time, and we say that massive objects create gravity by deforming space-time. We'll skip over the physics of this, but the important thing is that time moves more slowly when you're near a massive object in space. This concept came to the big screen in the movie Interstellar. Matthew McConaughey and his crew end up on a planet near a black hole where time moves more slowly than that on Earth.
What are you waiting for? Let's go. Go, 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 go. 7 years per hour here. Let's make it count.
This is called gravitational time dilation, and this idea helped to unify special and general relativity into one cohesive theory. And now, you understand gravity and space-time and light and planets, all from a patent clerk imagining a man falling off a ladder. That's our show this week. Join us next time, and thanks for listening.